All right, Samantha, the recording has begun.
Anna. Well, everyone, my name is Samantha Seymour, and I'm going to be your host for today's call on machine learning. And I want to thank you for joining Long Island Women in Tech at lunch. I'll quickly introduce myself. I am the Director of Partnerships for Long Island Women in Tech, and this is actually my first time hosting. So this is a very exciting event for me. My day job is as Director of Application Services and Maintenance for Altice USA, and I've been in the telecom and communications industry for about 20 years. So if Priscilla is ready, I would like to introduce her. She is our guest. And Priscilla, I'm going to do my best to not butcher your last name. So this is Priscilla Moraes, PhD. She is with us from Austin, Texas. She is I don't remember your exact title, but she works for Google, and she is is it a customer success?
Machine learning specialist.
Machine learning specialist. So welcome, Priscilla. And we're gonna get a little introduction from you and find out how you ended up in machine learning.
Thank you.
We really appreciate you taking your time and having lunch with us, or not eating, but having lunch with us. And so let's start with getting to know a little bit about you and your background.
Awesome. Okay. So thank you everybody for joining. It's really exciting. I was so happy when I saw the invitation, when I got to meet Stefan and Samantha, and they told me about the work that I knew about the Long Island Women in Tech, but I didn't know the outreach, all of the resources and things that are there. So I was really honored and kind of proud of being chosen to be here to share a little bit with you about my experience and what I do every day, and a little bit about what machine learning is. So to tell a little bit about myself. So I came from Salvador, so that's the city I was born. It's a coastal city in the northeast of Brazil, the state of Bahia. So Salvador, it's really known by music and tourism. So if you go to Brazil and you want to go to visit beautiful beaches, that's the place to go. Then when in 2008, my husband decided to do his PhD here in the US, and then we moved to Delaware, Newark, Delaware. So a little close to New York. So we would drive about 2.5 hours if we wanted to go to Manhattan and visit the city, and really close to DC and especially Philly. So we moved there. 2008, I didn't speak any English at the time, so I went to the English Language Institute there. And then I was rescued by a group similar to yours. So the Sisters AUD, and also the women in engineering there were the pillars for my interest and I think strength to go and pursue the challenge of doing my PhD. So after I studied a little bit of English, then I signed up for the program, and then I started the program there as well. Then about 6 years after, here I am at Google with my 2 babies. So six years after I joined the PhD, I started working for IBM Watson in 2014. So about 4 years after, I joined the PhD in 2010, and then I joined Google beginning of this year. So actually 8 years after I started my program, I got this job at Google, which it's really fulfilling because we are ahead in a lot of aspects. Now that we have amazing technology from all of the other vendors as well. So I'm really proud of being able to share my ideas and my skills doing the projects that we do here. So the pictures on the top right corner and the bottom left corner just to show the type of mom I am. We went to the Exploratorium Museum in San Francisco, and one of the challenges was if you were able to drink water from a fountain that looked like a toilet. And then I had kids do it. I hesitated a little bit, but I went there just to give the example. But yeah, but they were all, it's an amazing place if you have a chance. And the other pictures are they visiting me when I was onboarding, being trained in Sunnyvale. So now switching gears to what ML is. Why did I choose to work in this area, and why does it move me every day? Why do I wake up thinking about my job and sometimes go to bed thinking about my job? It is growing. I think if you on LinkedIn and all of the news, we see so many different advancements, either in self-driving cars or the advances in healthcare, right? Related to treatments of really difficult diseases, diseases that we cannot yet figure out. So that kind of gives us that idea that something's changing. And machine learning is a key component of that change, the shift in technology, the way we program systems now, the way we enable machines to do some of the jobs that in the past were just done by humans. Machine learning is a key component of that transformation. I also want to talk a little bit about the different roles that we can assume in that domain. But before we get there, I just want to kind of walk you through what does it look like? What is it that is that we call machine learning? And it's so broad, but what is it that how can we get a sense more or less of what it is? So, because it touches so many industries, right? So I mentioned here self-driving cars, I mentioned healthcare, finance, retail. So it's today, education, today any industry that you go will have a component, will have a piece of the business intelligence, the decision-making being either helped or completely automated with machine learning enabled systems. And that kind of causes an issue, and it is what we see today, is the lack of talent, because we don't have enough people to staff all of those positions that we have available today. And that's why some of the companies like Google, they're trying to automate so much the machine learning piece, enabling more and more people who don't have mathematical skills or algebra skills to be able to do it as well. So that's why it opens up a lot of different opportunities, even if you never took an algebra course, or even if you never did a calculus subject in college, for you to still do it now. So it doesn't necessarily, you don't need to have either a master's or PhD or even have done software engineering. You can still understand how to deal with the data that is needed to feed a learning model. You can still learn how to interpret the statistics that come out of a model. And those are all positions where you can get your way there by learning even after or adapting to what you do today, right? So that is one thing that I wanted to that's one of the messages I want you to leave with today. There is a lot of demand for the area. And if you're interested, if you like it, you for sure will find a spot that with your background and things that you do today, you can either apply to the job that you already do today, or even transform and change a little bit of what your day-to-day job is. So ways we see and offer ML today, and that links back to the type of jobs that we can do with that, with ML. So we usually see point ML tools, what we call. So those are services that do some sort of analysis, right? So let's talk about, for example, the task of identifying an image and understanding what that image is and labeling it. So this example here, if I got this image and I sent to a service that does image recognition, which is one of the ML areas that does vision, you probably return a label depending on how people who created the model labeled the classes. You could return piece of cake. You could return just cake. You could return chocolate cake or chocolate cake, slice of a chocolate cake. So it will capture the image and then understand what it is and then classify, try its best to describe it. And it does that because it was provided data to train what these patterns are that map to that class. So in other terms, machine learning, and we're gonna get to the official, to kind of a formal description and definition of what it is, but it is basically, can I use algorithms to enable the machine to do the same thing I would do if I teach it? If first I show it a lot of examples and cases where you will define patterns within itself. So the algorithm will be responsible for finding patterns that will allow the machine to reach the same conclusion that I would reach. So we have different algorithms for the visual piece, right? So some specific models would apply to the task of doing vision recognition. Other algorithms would apply to identifying the task of natural language recognition. Other algorithms would specialize in listening to audio, to wave sounds, and then translate that into words, right? First phonemes, then words, and then doing a transcription of the whole audio. So we have, within machine learning, different algorithms that would specialize on doing these perception tasks, but we need to provide information beforehand to be able to teach those algorithms. So you need to have, yes.
So machine learning is a subset of AI then?
Yes, yes. AI, artificial intelligence is broader, and it does have other things such as search. So yeah, so artificial intelligence can use rule-based approaches, which is a little different than the teaching mechanism. So the rule-based approach in AI, you would define what the sequence of patterns are, right? So you can say, okay, if X, Y, and Z, then take action W, right? So you'd kind of define, that's a rule-based approach. Mm-hmm. Because we need a lot of human hands-on on that process to kind of define all of the rules. And if anything changes, we need to go back and change the rules so that the outcome now is correct. It became a little overwhelming to do things with rules, right? So that's when machine learning kind of started coming, and we started trying to see if it could transfer the definition of the rules to computers. Mm-hmm. We would provide the input and the label, and then the way they get there is what machine learning would do. But yes, it is a piece of AI.
Okay.
Yeah, it's correct.
Thank you.
So we do have today a lot of different services that are available to do, for example, transcription of audio, get from text to synthesize audio, so synthesize speech, right? So that is text to speech. The transcription has speech to text. We have natural language processing tools that will allow us to identify particularities of the text, such as entities, so proper nouns or names of places or organizations, some specific entity types. And we have, within the natural language processing piece, we have a lot of different abilities, such as recognizing the sentiment. If somebody writes something in a review and they're not as happy, we have a lot of different tools out there, open source, that, for example, today, if you want to assess how your customer is evaluating your services or your products, and you have access to those reviews, you can run them through these tools and then be able to identify if they're happy, sad, or if they're just neutral, right? So those would be the common outputs of a sentiment analysis tool. And then the vision that we described, right? We have, for example, we have customers here today that they implement surveillance. And then, so that is taking each frame of the video, sending through recognition APIs, and trigger when there is any offensive or malicious behavior. Either if it detects a gun, you should trigger, or if it detects something inappropriate in a given setup or scenario, right? So that is one example of how machine learning is applied on all of those different use cases. So let me pause it. Should we ask questions now, or if the questions come, you're gonna let me know, Sam?
Okay. I don't see any yet, but I actually have a few questions for you.
Okay.
You know, emerging technologies are very popular topic right now, and machine learning and AI fall into that space. But is machine learning really new, or is this something that's just been evolving for a long time?
Oh yes, so it's been there for a while, in many different forms. I think I loved a timeline that that Google posted in a news once in a blog, with dates and times where things kind of map to some sort of machine learning. For example, we had, I don't remember the first one in history right now, I can recall, but some more of the recent ones, we had IBM Watson win the Jeopardy game, right? So the Jeopardy game, and that was about when I was starting my PhD, and I was like, oh my God, I can't believe it. I can't believe that a computer is able to answer those questions. So if you're not familiar with Jeopardy, so they have cues, like provided in natural language, and people come up with what the answer would be based on the cues that the presenter provided. So the game, the computer was there playing with the two winners, the winner that won the most amount of money, and the winner that won the most amount, the higher number of games. They were both of them there playing with IBM Watson, and he won the Jeopardy challenge. And that was in 2012. And that was a moment where we said, wait, right? We don't know, we didn't know the machines could get to that point. So there are a lot of things we can do with that. And that was when a whole division at IBM started to use that technology to go and touch different points in industries such as healthcare and others. Then Google went and won the Go game from I think the winner, the worldwide most known Go player, because he always won. He never lost to anybody. And then DeepMind, a company that we named today, it's ours as an acquisition. So DeepMind with Google at the time, they taught reinforcement learning algorithms, and reinforcement learning is a specialty piece of machine learning, to teach to on the fly, on real time, while playing, make the decisions of where to go. And Go, I think, it's a more complex version from chess, because the possibilities are endless, the moves that you can make. So I think from 5 matches, the human won 1, and then the computer won 4, if I'm not mistaken. But there is a documentary in Netflix that talks about that, that shows the whole process from the DeepMind team identifying how to teach the machine to play the game. Mm-hmm. And it would learn it by itself, what should do next, instead of the programmer entering that information.
Interesting.
That's what reinforcement learning does. It plays with itself,
right?
And then it identifies defaults, and it learns how to overcome the mistake that it made before.
Right.
So that's really good with all of the possibilities.
So I don't know if you've seen this. I believe the movie was from the 80s. There was a movie called War Games.
Yes.
Matthew Broderick.
Yes.
So it sounds like that is just came
Yeah.
came to be in that 20. When did you say Google did that?
Oh, Go, I think was 2015 or 16. Yeah. Yeah, Watson was 2012 and was different because it was a natural language task.
Okay.
Go was more of a strategy, but was using reinforcement learning, which was not new technology. So all of those were, we started doing deep learning. And deep learning, we can have a separate just on deep learning because that's just mind-blowing as well. So deep learning, it's also really quite old, decades ago. But now that we have the infrastructure, the hardware that can run those models in a timely manner, then that's when it's coming back now with more and more tasks, right? For translation of between languages, for processing text and all of that. So yeah.
So do you think that the evolution of the hardware and the ability to increase the processing has moved this forward much faster, since machine learning has been around for a long time, but the ability to calculate all the permutations has really just dramatically increased in the last 15 to 20 years, that's why it's come to where it is?
Yes, definitely. And then I kind of will talk a little bit about Google's specific hardware design to do machine learning. It's called TPUs, tensor processing units. And those decrease by 10 times time on training models. So we ran on benchmarks from Stanford and models that used to run for 17 hours and now run for an hour and a half, right, for example. So that, because the hardware is designed just to do the matrix multiplications, right, that specific operation that the deep learning uses so much. So then that allows us to turn around faster, because part of a machine learning model development is for you to find the data, and we're gonna talk a little bit about that. But finding the right data, right, and the data being properly labeled, then you need to write the model, and then you feed that data through the model, and for that you have different algorithms depending on the task that you wanna perform. But then once you've done that, then you evaluate. You evaluate by running on data that was not used to train the model. So you get a new subset of data, and you run and you see how your predictions came out. So if they came closer to what was learned from the other, then you have a good accuracy, let's say, right? So if you predict it correctly, then you have higher accuracy than if your model doesn't do as well. So once you look at those evaluation metrics, then you come back and either tweak the model, right? You change the learning rate, and those are a lot of different hyperparameters that can be changed in an algorithm, in a model to perform better. Or you can also modify the data, provide more examples for the classes that are not doing as well. So there are all of those different pieces of the pipeline, of the lifetime of a model development. So because you need to do all of that, if it's taking a long time to train, right, on CPUs, for example, then you cannot do as much. And then we came with GPUs now. NVIDIA has a good set of GPUs, really advanced hardware as well, that allows us to do more. So then now your turnaround is a little lower, so you can then come back and review it, model the data faster, and then go and modify it and keep training, right? So, and then CPUs now increase that speed. The speed up is even higher.
Okay.
So yeah, it has definitely changed the way things are.
Okay, it looks like I do have one question. Are automated translation tools a good example of machine learning? They've been around for a while. An example, maybe Google Translate.
Yes. And that's great. So yeah, so translation, we have phrase-based algorithms for translation. So that would be, okay, so if I see this noun, right, or this verb, I'm gonna map to that verb. So alignment of the sentence pairs in the two languages that you wanna translate from to, right? And then the phrase-based will be learning how to map those things. It's HTML. Now we have a new algorithm in machine learning that it's called neural machine translation, which is also ML, but is an improved version that from papers and evaluations, we see that it performs way better, right? So neural machine translations it's one of the implementations of deep learning algorithms that use sequence-to-sequence models. But that is getting too specific. So just think of, okay, so we do have the task translation, and then there was a way that we used to do before. It was still AI, was still learning because we're teaching the machine how to identify source and then target, right? But now we kind of keep improving and making changes to the model. So now you have new versions of the Google Translate. So we just now deployed the translation that when you say translate.google.com, it uses neural machine translation, which is a deep learning approach for doing the same task that we used to do before with statistical language modeling. If that makes sense.
Very interesting.
Okay.
All right, so we have another question. Let's see if I can get this one right. So previously you mentioned there's a lack of talent at present time. What would you suggest for an educator to concentrate to train these talents? And what skills do you use most every day at work?
Oh, awesome. Okay, yeah. So the first question. So so I'm in a team of 15. Let me just give you a picture. So my team of machine learning specialists to cover United States, Canada, and Latin America, there are 15 people. And discounting the fact that it's hard to get in Google, people try a couple times. Besides putting that aside, even within the team, within our 15, not everybody is specialized in all of these topics that I mentioned, right? Not everybody is in vision, not everybody is knows about speech. So we kind of have that stratified, siloed set of skills, right, from people who specialize in those things. And our job is primarily to help customers on board on GCP. So today what I'm doing as a machine learning specialist is to identify how I can help my customers to get their problems solved by machine learning on our platform. So let's say that tomorrow we have a customer that requests something around natural language processing, and they are in the East Coast, right? And you're there. So we have a couple of people in the East Coast, but not all of them are in NLP. So even within machine learning, there are those little pieces that we constantly train each other on these different topics. So that's something that I've been pushing strongly, and I've been taking not a lead, but I'm doing that myself. I'm sharing more the content that I know, things that I learned throughout like 6 years. I'm trying to compile them in a way that enable my colleagues that specialize in vision to go have a conversation in natural language processing, for example, right? So that is something definitely that my leadership approves and incentivizes. So if you have anybody in your organization, your team, that knows, logistic regression, they've done models in logistic regression, I would strongly suggest me as you, that teammate or that person, or even if it is you who holds the knowledge, to have lunch and learns, to share what you know with your colleagues, so with people in your team that also could benefit from running a logistic regression model to do analysis on some data set that you have. So that is when there is already some set of skills on the team, and you wanna democratize that, right? When it doesn't, when nobody there knows, but it is identified that the need exists for that, there are a couple of options. If we do not want to go for the existing tools that we can just use, they're out there, self-serve. But if you want to develop things in-house, courses in Coursera are a great option. So asking the employer to even if the employees could take the course on expense, or some of them are free. Google does have a couple, but the ones from Google are mostly on how to run those workloads on GCP. But if you want to learn things to do on your own, Stanford made available courses around machine learning through Andrew NG. That's his last name. He's no longer in Stanford, but he had great material on Coursera that gives you the base of what machine learning is and how to design those models and all of the different classification tasks. So if you can do regression, you can do classification, you can do clustering. So it talks about all of those different things, and then you start seeing, oh, okay, so that problem, that thing that I do, I could use a regression algorithm to help me, or it allows you to identify those, how to map the use cases that you have with specific pieces in machine learning so that you can dig deeper, right? Once you identify those. So there is great material out there. Udacity, as a couple, I did prepare one of the nano degree courses when I was in Watson for them as well. It talks about deep learning. It goes in a sequence that makes sense. So you won't be thrown with a lot of math right out the bat. So it's a good paced presentation of the content. So I definitely recommend some self-learning. You don't need to go back to school to learn how to do machine learning. You don't need to go, oh, now I need to go back and do 2 years of math. No, you don't. So these self-learning courses will allow you to pace your skill acquisition. So you determine if you want to finish a course in a month or in a week, right? So depending on how much time you have available. And it's great because there is support from the community, so you can ask questions. It's really interesting. So I would definitely at least take a look. Sometimes it's just for the matter of, you might not use it today, but it might help you identify better ways to solve the problems that you have in your hands in the future. So it's like swimming. It's a good skill to have, just because, not that you don't actually need to do it every day, but if you are in the computer science space, knowing what could be applied where, even if you go just to find the right tools, they're already available, even if you don't want to write the model, right? Understanding what the whole process is and how to solve problems using machine learning allows you to find the right tools and go to the right providers. So for example, if you're evaluating, if you want to run a POC, or if you want to do a proof of concept for one of the workloads that you have, then you're evaluating between the vendors, knowing what they are presenting to you and having some sense of what should be the questions that you want to ask them. That's a good asset, right? That's a good thing to have. So I would recommend ML just as a basic. Today, I don't know how these schools are having their curriculums now defined, because I didn't do my undergrad here. Machine learning for the grad course was required, was not optional, right? It was part of the core courses. But for the undergrad, I think we should start injecting, because it can apply to so many different things. I think it should be natural already, how to see how we can improve methods by using emerging technologies. I think that should be part of the curriculum.
Okay. I have another question. This one's a good one. Not that they aren't all good, but is text analytics at a point where we can rely on it to interpret market trends? The context for the question comes from a recent article in the New York Times about Siri versus Alexa. The article made the point that if you ask the same question, you may get different answers from different AI systems. So if I use AI to analyze social media text and use the results to make a business decision, how reliable is that tool?
That's quite deep. Okay, so okay. First, let me address the Alexa versus Siri, and even if you ask, hey Google, you might get a third, right, different answer. So those conversational agents, they're designed by humans, so they will have the bias of the human. So it's like, so today, if you search a query on Google, then you get the set of results. And then it's kind of up to you to go there and kind of browse it and see which information is more relevant and which one kind of makes more sense to you. Some of them will be reliable, some won't, right? So when we're designing a conversational agent that is supposed to give you the answer, we need to be careful. And that, so hey Google, when you ask, if you ask anything that is beyond what the user model learned. So for example, my Google Assistant knows who my husband is, my sister, the names of my daughters. It knows everything about me. It built a user model. You will learn. If I say, can you call my husband, doesn't know who my husband is. I will say the name, you'll find the contact number. And now next time when I say call my husband, is gonna call his number already, right? So it builds that knowledge of myself. If I ask anything beyond that, beyond what was provided by me as information, you will probably search on the web search and say, according to blah, 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 that's what I found, right? So that is it's a search and rank tool, which is text analytics, but it's not Q&A, right? When you go to a Q&A scenario, the response will be as good and as reliable as the data that you provided to the model to find the answers from, right? So it's a lot of the ethics involved in being able to provide good information. It starts from the very beginning, where when you ingest documents to train your model, do from reliable sources, right? And if that happened, then, for example, if you're in a healthcare setup and you're using a conversational agent to help you find answers about certain treatments for cancer, if you ingested peer-reviewed papers from PubMed, then the likelihood of those answers being reliable is really high, right? You might still find disagreement between authors or between papers that were found that were older, but there is a more recent one that would indicate a different treatment for that. So it will, but if you ingest everything on the web, you're gonna find a lot of things that are not as reliable. So so the question, I really liked the way you put it as well, when you said is text analytics reliable for us to make decisions? And so that's why most of the models that we design or we recommend, they're not making the decision for you. They're surfacing information that might be hard to find, right? So they are going through billions and billions of documents, for example, and find you the top 100 that you might want to take a look. And then from these top 100, you might want to skim some of them and then just get down to 10. And then those 10 you're going to read through. So that is the objective of those tools, is to leverage your intelligence, to leverage the technology to allow you to use your intelligence in more important tasks or more delicate tasks, or at the end making the actual decision. So I know that there is people trying to get so even for example, Watson Health is one example. Watson Health suggests treatments based on the patient's history, based on the patient's current symptoms, and then it looks at the literature, it tries to map things, but it's not saying go and do treatment A. It says, so here are treatments that I found relevant. Here's my confidence on suggesting you to do these, but the ultimate decision is from the physician to go read through the list, discuss with others, with the board, and then decide, right? So that is how I would say we should be focusing our efforts on using ML. Is how can I automate some of the tasks that will help me save time, and then I still use my judgment, right? Because machines cannot replace us on the human side. So a lot of things are way beyond the black and white that is there on the bits, right? That we feed the machine with. So a lot is really it's sensitive are sensitive aspects that I think only the human mind is able to make a decision upon. So those are, I think, yeah, I would say it is real. So in summary, and I know it's a long answer, I talked too much. Yeah, I think in summary, it would be being really careful and diligent on choosing the right sources of data that you want to use to train the model. That's the first step. Once you've done that, be even more diligent on evaluating what is coming out of your model, so that then when you get to a point where it is consistent and reliable, then you can deploy, right? And use that to guide anybody to make any decisions. And then always have the human component at the end, making the actual decision instead of just relying on what the machine said or recommended. I think
So
that
that's
would be
great advice, and will probably bring a lot of people comfort. So it's 12:47, so I'm just going to make sure we have a time check here. I have a really good question, and then I'm not sure if you had more information in your presentation that you wanted to cover. But
I think we've only got to half. The only
okay.
thing, let me just one thing. So this was the kind of the definition: ability to give systems, ability given to systems to learn progressively, improve performance on a specific task with data. So this ability happens without the need for explicitly programming, right? Those tasks. But one thing that I wanted to show was a quick search that I did on Glassdoor. I did that, okay. Yeah. First, I searched jobs that mention machine learning anyway in Long Island, and that came 4,000. But then I narrowed the distance to 5 miles, and I found maybe I think 200 and something jobs that mention machine learning. But if you look at the descriptions of the positions, they are not only data scientists, or they are sometimes software engineer, but they require some knowledge of machine learning. So that is what I wanted to kind of touch on before we leave today, just to keep your eyes out. So this is a software developer full time, but at some point there is a component where they mention either in the preferred skills or on the required skills that they mention some machine learning skills there as well. I think that's it. Yeah, and the other one was just examples of Disney and Urban Outfitters using machine learning, but I think the questions are more important. So let's talk about it.
Well, I just wanted to make a point. I like how you mentioned the importance of self-learning and the tools that are available freely out on the web to help educate on this concept that is talked about quite a bit in the industry, and you know that you may not need to go back and get that third degree to be successful in this space, or to speak intelligently about it. So I think those are some useful tips that you provided, and I'm sure we can find somewhere to post that in our blog when we write up about this webinar. We'll make sure to have that included. All right, so the good questions that came through, I really liked this one. So what are your thoughts about ML and AI being used by Facebook social media, or Facebook.social media, to help distinguish between real news and fake news?
I think it all comes down to the concept of fake news, right? Because so for some people, fake news are coming from a specific venue. That's what I've been seeing and reading. They're labeled as fake news because they came from that venue versus the other venue. Some other people might define fake news as that it's actually reports of things that did not actually happen. I'm not familiar with Facebook's algorithm for determining if the news is fake or not. I would probably need to read more about it. I see that it's a hard task. It's a really hard task because unless you have somebody that can attest that those things did not happen, it's really hard for you to determine. So there are algorithms that could allow us to see by how many times such thing was mentioned. Because usually when the news is news, some trusted sources, a couple of them, we will at least mention. So there are ways for us to assess if that only came on that specific blog post, right? But nobody else talked about it. But it's really, we would be able to surface it and then do a deeper evaluation to see, right? Because it might be so new that the person who found out about it blogged it, but others will still do their due diligence to go search for facts and then post it. On that timeline, it can be flagged as fake, right? And that's just an assumption of that,
unvalidated, essentially.
Yes, exactly. The uniqueness, right, of the content. If I'm assuming that could be one of the aspects that they're looking at instead of, so if they don't have supporting evidence, I'm not trusting you as much, right? So that is the false positive as fake. If that was the case, it was on that window that nobody else talked about it. But knowing all the facts to then cross-check if some news are so you can narrow your space by saying, no, I'm looking at the headlines. So I'm looking at the headlines and then I'm assessing if that's true. So let's say we have a headline saying US and China trade is solved now, which I don't think it is, right? So let's say that somebody blogged that thing. So they figured it all out, and that's the headline of the news. We would need to have a real-time knowledge base, a knowledge graph that knows all the facts, so that when we get that sentence and we break down the entities and we get the relationship between the entities and we run through that knowledge graph that knows everything, that oracle, and we don't find that fact there, that is when the process is completely automated, right? So if you didn't find the fact present in that knowledge graph, then we could flag it as fake, right? So as I mentioned, I'm not familiar with Facebook's algorithm, but those are ways I see something like that could work, could be implemented. But if you're talking about crossing facts, we will need to have that to automate the process, to not have a human involved. We need to represent the truth and the overall knowledge in real time in some sort of structured representation. So a knowledge graph would give that structure. So you have like US, China, and then you have something like an arc with them saying a trade or something like that. So that's how we have our knowledge graph here that helps us search. But if you have that by the minute, by the second updated, then you can then get your sentence, your unstructured data, map it to that graph and see if it checks, right? So that would be one way. So I don't know what technology they're using, but I for certain take a look. And I guess it's valid. So my thoughts are, and I think you asked my opinion.
Yes,
right?
Your opinion.
My opinion. I don't know. I think I'm pro technology. But I think we need to be careful.
Yeah.
So depending on the repercussion, depending on the impact that whatever we come up with will have on people's lives, and I don't know. So if it is going to discredit the blogger, I would be really careful on how I would flag it or what I would do it with the outputs of my system. So we need to be really careful. I think ethics is all about, okay, you have the ability to do it, doesn't necessarily mean you need to do it or you should do it. So it's like evaluating if it is helping more than harming, I would say. And I think in that balance, if the help is bigger, I'll probably be pro. Yeah.
Okay.
I don't know if that answers, but.
I didn't want to interrupt too much. I just wanted to mention that I met somebody at I was on an AI talk panel a few months, maybe 2 months ago. And I met a CEO of a new startup that's in the research phase for this type of technology. It's called Skim AI. I put the link in the chat if you guys want to try it out. He's trying to obviously get data to build those algorithms. So the more people who test it out and do the download, the better it will get. The more data, the better. I think he's struggling with that same challenge that you mentioned, is if I don't have the real fact, I won't be able to be able to determine truth versus false, if anything's true or false. I also think that there's a setting that he's working on that's focused on truth versus opinion, right? Mm-hmm. So I think that's a little bit easier to determine because opinions are presented differently, and natural language wise, you can feel that out based on how things are written. So that's what he's been researching. It was a really great discussion I had with him after the session, so I wanted to share it with everyone.
Interesting. Mm-hmm. All right, well, we are at 12:57. There is actually quite a bit of positive feedback in our chat session, and I guess you have about 1 minute to wrap us up with a final thought. And I believe a lot of people would love for you to come back and speak with us. So we would probably like to talk with you about that after, we close this out.
Awesome. That's awesome. So I would love to hear what you guys want to hear about. So there are things that they'll say, oh, that I probably won't have I'm not the right one. I don't have the credentials to talk about that. But if I do, I'd love to share. I've done a couple different jobs that touch machine learning throughout since I was in Brazil, when I taught, and then coming to Watson and then now Google. So I would love to either talk about the business side of things or even more technical. So if it is of interest for us to kind of dive deep or talk about deep learning or talk about some specific use cases for all of those different ML problems that we solve, I'd love to. So I just want to say thank you so much for your listening ears. Thank you for spending this hour here. That's something that I'm really passionate about. So every time I have the opportunity, I just jump right in and I talk about it because I love what I do. But yeah, so sorry if I could not address all of the questions because I just talked too much, but I'm working on it. my daughter says that all the time. Okay, mama. Okay. I'm like, that's my cue. Like now I'm time to just shut up. So yeah. So thank you so much. And then please add me on LinkedIn if you have questions. I try my best to answer them in a timely manner. So if you want pointers or things or material, courses, I will try my best to address them and to answer. I did have a couple of people that connected with me right when we posted the webinar, and I loved it. So if you were one of those people, thank you. I love to have you on my contact, and so we will be in touch, I guess, and I would love to come back.
Great. Your passion for this is contagious, and it was a pleasure having you, and we can't wait to set up our next event with you. So thank you. Yeah. And thanks everyone for joining. It's been a really great session for my first one.
Thank you. Congratulations, Samantha, and thank you, Priscilla. Bye, guys.
Bye-bye.